Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 22, 2026, just 4 days ago. It introduces a unified framework that achieves state-of-the-art performance in joint audio-video generation using only around 1 million public training entries. The paper is titled JavisDiT++, Unified Modeling and Optimization for Joint Audio-Video Generation. And as we'll see later, the resulting improvements in synchronization are really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. On Hugging Face, the JavisDiT weights are available with inference code and training instructions, making it easy to start generating your own perfectly synced audio and video clips. To see this in action, Figure 1 presents several generated examples. In the top sequence, depicting pigeons, notice how the audio waveform tracks the video events. The green audio segment aligns with flapping wings, while the orange captures the splash. Moving down, the bottom left example features a brown bear, where the growling sound is timed to its movement. On the right, we see similar alignment for a piano player and a racing car, proving the model handles diverse semantics effectively. Well, Figure 2 quantifies this progress with a radar chart comparing the new framework against prior baselines and a top-tier proprietary system. The axes track 6 metrics, including video quality, audio quality, and synchronization. Notice the small inner shapes formed by the blue and green lines, which represent previous methods like JavisDiT and Universe 1. In contrast, the red line for JavisDiT++ expands significantly outward to cover a much larger area. This comprehensive gain nearly closes the gap with the commercial VO3 model, represented by the outer cyan boundary. So, Figure 3 reveals the architecture of JavisDiT++. On the left, separate video and audio tokens are synchronized using a technique called temporally aligned rotary position encoding. Inside the central block, a shared self-attention layer allows these modalities to exchange information directly. Crucially, the flow then splits into 2 distinct paths, a video feed-forward network and an audio feed-forward network. This separation prevents the different signal types from interfering with each other before they are finally decoded on the right. So, Figure 3 introduced the concept, and now Figure 4 zooms in on exactly how the temporal aligned rotary position encoding works. The central feature is the unified timeline, represented by the green arrow, which forces both modalities onto a shared clock. Above the arrow, video tokens at time steps 0, 1, and 2 are arranged spatially. Below it, audio tokens use these exact same temporal indices, which ensures they align frame by frame. To distinguish them, the system offsets the spatial coordinates, the second and third numbers in the brackets, so audio occupies a different frequency lane while keeping the timing identical. Alright, while the previous figure handled low-level timing, Figure 5 outlines the training pipeline called Audio-Video Direct Preference Optimization. On the left, a text caption feeds into a reference model to generate multiple candidate audio-video pairs. These candidates pass through the reward models block in the center, which evaluates them on audio quality, video quality, and synchronization. The resulting scores on the right identify winning and losing pairs. This ranking data then loops back into the AVDPO module at the top, teaching the model to align with human preferences. Well, Figure 5 explained the training, and now Table 1 presents the quantitative results on JavisBench. The table compares cascaded systems in the top sections against joint generation models at the bottom. Focusing on the final row, JavisDiT++ achieves the best performance across almost every metric. It lowers the free-shave video distance to 142 and audio distance to 5.5, beating the massive Universe 1 model. Synchronization also excels with a desync score of 0.83, all while running 3 times faster than the previous version. To wrap up, JavisDiT++ demonstrates that open-source models can now rival proprietary systems like VO3, achieving high-quality synchronization with surprisingly efficient training. This unified approach marks a significant step forward for accessible, synchronized multimodal generation. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.